Hello, everybody. Coming to you from Brecksville Broadview Heights High School. Hope you're having a great day. And today we're going to talk about triangle similarity. So triangles exclusively, and we want to be able to show whether or not they're similar. So we need to know what similar means. Similar means the same shape and not necessarily the same size. Okay? So we got three ways of showing it: angle angle, side side side, and side angle side. Okay? So for example, if I have these two triangles here and this guy over here, again roughly making him look to be the same shape but bigger, think Xerox machine. Okay? So if I know, for example, this is the same measure as this guy, and I know, let's take a different color here, say this guy is the same measure as this guy. Well, let's think about that. Let's plug some numbers in there. Let's say, for example, this is 40, and let's say that this is 70. Okay. Well, the things that I know about triangles is they add up to 180. So I would know that this third angle over here would have to be 70. And likewise, so if I had the same thing going on here, 40 and 70, this also would have to be 70 down this bottom right hand corner. And I would have, so I only need two of the angles, and it's kind of a use of the third angle rule to show that those third angles are also congruent, therefore the triangles are similar. Okay, so two angles, if I have two angles congruent in two triangles, they are similar. Side, 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 well, if I have uh, this triangle here, side lengths of, let's make this 3 here, and 1 here. And then I have this other triangle, making this guy 6 here, and 2 here. Well, the ratio is the same of all of those. In other words, over here, 3 is to 6 is the same as 1 is to 2. So the scale factor of that guy would be 1 to 2, going from, let's call this triangle A, call this triangle B, and basically, if I'm going from triangle A to B, my scale factor would be 1 to 2. From B to A, it would be 2 to 1. Okay, so if all three sides are similar, hold the same ratio, then we have something that's the same shape but different size. Okay, the third way, again, we're still talking about triangles here, okay? Side angle side. Well, let's take a look here. Build one of these guys at 7, 7, and put a 30 up here. And build this guy as 14, 14 with 30 up here. Okay? That would be enough, okay, to show that those triangles are going to be similar. What you're going to end up with, in this case, actually, you get these angles must be the same, because if the sides, then the angles, and then that's enough right there. But anytime you have side angle side, that's enough to show that the triangles are going to be similar. In other words, side angle side, the ratio of the sides holds and the angles are congruent. Okay, when we're talking about sides, we're talking about ratios. When we're talking about angles, we're talking about the same measure, same number. All right, let's go ahead and get into some examples here, and these go pretty quickly. So the first example here, are they similar or not? Well, once I know over here, we'll call this again A, we'll call this B. In triangle A, we've got the same marking here on the bottom here. We've got the same marking here on the top as here. So I've got two angles, so I don't really care about the numbers. They make no difference. This is basically, I can state that these triangles are similar, and my reason is angle, angle. Okay, so I have to have one of these three reasons. In this case, it's angle, angle. Okay, now this guy down here, this is a good one because this is like in the lecture here. I honestly do think this is probably the best question for you right here. So let's take a look at this guy. Extend this a little bit. Okay. All right. So now I need to kind of match up the sides. Again, we'll go triangle A, triangle B. All right. So in triangle A, um, the 14 matches with the 17.5. Okay. You just kind of have to line things up. I can definitely start with, and I probably would start with this 16 and this 20. So, okay, so 16 is to 20. Let's go ahead and simplify that. So, 4 goes into 16 four times, 4 goes into 25 times. So I'm looking to see if 4 to 5 holds. Okay, that's what I'm checking. All right, so now the 12 and the 15, does that equal 4 to 5? Well, let's see. 15 times 4 is 60. 12 times 5 is 60. And any times those have the same numbers, I'm all set. So now let's check the last one, which is 14 to 17.5. Does that equal 4 to 5? Okay. Let's see. 14 times 5 is 70. And 4 times 17 is 68. Plus 2 more is 70. Yeehaw. Okay. So these triangles, they're not all congruent, but the ratio of the sides holds in all three cases. So we would say that A is similar to B. That's your sign for similar. A is similar to B by, and the reason is side, oops, side, side, side. Ooh, boy. Okay, the reasoning is side, side, side. Okay, the ratios hold. Okay? All right, let's go ahead and move into the next couple examples here. And this is basically your skill. Two triangles, are they similar or not? That's your lesson. I mean, there's nothing more really to it. Okay. Example 3, let's try these ratios out. Let's go in triangle A, let's go 5 is to 9. Well, that's our ratio. And see if that holds with, in triangle B, the corresponding sides are 2 and 6. 2, 6. So 5 times 6 is 30. 9 times 2 is 18. Those are not equal. So right away, my only shot was side angle side, right? But that has to be a no because the ratio of the sides doesn't hold. So this is not similar. Okay? Let's look down here at this guy. Okay, number 4. Okay. So I'm looking for side angle side, and let's see, we've got, let's go match up the 8 in A with the 12. Let's see what that looks like. Um, Actually, I did this one, yeah. Uh, 8 is to 12. Is that the same as 6 to 9? Okay, I could simplify this if I wanted to, but quick and easy, 8 times 9 is 72. 6 times 12 is 72. So these both break down to the same, basically the same ratio. Actually, wait a minute. 8 is to 12 is 2/3. There we go. Okay. 4 goes in twice. 3 goes in twice. Oh, shoo. Okay. So that just looked funny for a second. Um, so 2/3 for both of those. So this works. So I've got side, angle, side in both of these as far as the angles are the same by the marking, and the sides, the ratios hold. So I've got side, angle, side. So A is similar to B. Okay. A is similar to B by side, angle, side. All right. Let's look at this guy. Are they similar? Well, before I decide whether they're similar, the numbers aren't the same, but I got a 51 that's the same, so that's a good start. And I know these are triangles, so it's pretty sure that I need to figure out what this third side is. So 180 minus 75 minus 51 equals 54 right here in triangle A. Over here in triangle B, kind of doing the same thing. 51 and 54 is 105 plus the 75 here makes 180. Now, I can take any two of the three. I can take, uh, let's take this guy and this guy. Yes, match the one we've already talked about, and I've got angle, angle. So A is similar to B by angle, angle, and it's easy to see that all three are the same. Okay, are the following similar? Well, don't have to do a lot of work here because I've only got two sides, okay? I don't know anything about the angles. The only thing that would have saved me here is if I had a right angle marked here, then I could find the third side and I could do a lot of different things. But since that's not marked and side isn't one of my choices, then this is no. Not similar. In other words, they may be similar, who knows, but I can't prove that they are. And then this last example here, going back to our previous knowledge of what happens with parallel lines, well, I get alternate interior angles here and here, and I also get alternate interior angles here and here. So right away I'm done. I mean, we all know that we have vertical angles in here as well. So I definitely have angle, angle, and I have similarity. Okay, so now we're going to take this into a couple problem settings, and that'll be that. How tall is the building, we say. Okay, so we're implying right here that we've got basically a right angle at the ground here and a right angle in here. So I've got angle, angle similarity. So right away I know the triangles are similar. So let's go ahead and set this guy up. Let's just stay in the triangle here. In other words, use two out of the same guy. So 6 is to 8. Let's go ahead and simplify that to 3 over 4. And that must equal to, well, the 8 was the 8 is to the 30. So if this was on the bottom here, this 30 has to be on the bottom there. And my unknown is the height of the building. So x right there. Let's go ahead and run our math. Cross multiply. 4x. If this distracts you, you could get rid of this at this point. 4 times x, cross multiplying here to here, is the same as 3 times 30, there to there. Okay, so x equals 22.5 feet, and that's your answer, the height of the building. Pretty simple. Nice little problem, but not too difficult. Okay. All right, the very last one. Maybe I should write on here that they're similar by angle, angle. Cool. All right, last one, and we're going to just make it looks like. We have these two figures here, and I want to find x and y. Well, they're similar because of angle, angle, because these are corresponding angles because they're marked as parallel. Without that marking, I'd be stuck. Okay, so for x, we got 4 in this top triangle is to 3. Let's take two sides out of that triangle. And in the big triangle, the 4 compares to the 4 plus x. And on the other side, 3 plus 6 equals 9. Okay, so that's going to allow us to solve for x. So 3 times 4 is 12. Well, let's go ahead and write this out. And 4 equals 36 going the other way. 12 plus 3x equals 36. And 3x equals 24. And x equals 8. I'll talk about y in class because I'm running out of time here, so I need to go ahead and stop this. Hope you're having a great day, and we'll talk to you soon.